Hey everyone, welcome back to Ironics.ai. In our previous video, we explored the difference between AI, machine learning, deep learning, generative AI, and large language models. And many of you ask, okay, but what exactly is a large language model? How does it really works? And how can I actually try one out myself? Well, today's video is a deep dive you have been waiting for. We'll explore the science behind large language models, look at the real world demos, and even see how they work internally with hands-on examples using ChatGPT, Gemini, Claude, Llama, Grok, Perplexity AI. So let's get started and understand the brain behind modern AI. First of all, question arises, what is LLM? LLM stands for large language model. It is large because it is trained on a massive amounts of textual data. It is language model because it understands and generates human language. Think of it like a super powered version of your phone's autocorrect. But instead of predicting a single next word, it can generate full essays, summarize articles, translate text, generate images, write code, and even have natural conversations. Now, before we get into how LLM work, let's actually see them in action. Let's open some of the most popular LLM powered applications where we will explore ChatGPT, Gemini, Claude, Llama, Grok, Perplexity AI, and we'll also talk about transformer architecture. And for that, let's go to the Google tab. I'll open ChatGPT by just typing chatgpt.com. I'm writing the prompt, write a funny poem about AI learning to cook. You see how creative and structured the responses. This is powered by a large language model, in this case GPT-5. Next, let's open Gemini by Google by just typing Gemini online. We're opening a new chat. Then we are giving a task, summarize the concept of quantum computing in one paragraph. That's also an LLM trained on Google's vast corpus of text and code, as you can see. Now let's go to Claude.ai by just typing Claude.ai online. I'm asking, write an email declining a job offer. Notice how natural and human-like it sounds. Again, thanks to the underlying LLM architecture. Sonnet 4.5 in this particular case. We can also change the large language model from here. That is also an LLM. Then we have LLaMA 3 model by Meta. It is a Meta's open source large language model. We are just typing LLaMA 3 Hugging Face. It is available on Hugging Face and developers use it locally for chatbots, summarizers, and question answering systems. You can give your prompt or question over here and it'll generate the answer for you. If you want to download this particular model, you just click on files and version over here. You can download it from here. If you want to use this particular model, click on this link. Then you can open the Google Colab. In this particular Google Colab, we'll be having a piece of code with which you can run that particular large language model by Meta, which is very famous right now. Let's check Grok X. This model focuses on real-time knowledge from X, formerly called as Twitter. For example, if I ask, what are the latest AI breakthroughs this week? Grok gives current internet connected results. An LLM with a real-time browsing. Insane. Finally, let's open Perplexity AI by just typing Perplexity on Google. It is a great example of an LLM connected to the web. It doesn't just generate answer, it also cites the sources. That means it uses an LLM on top of retrieval based knowledge. So I'm clicking on continue with free. I'm clicking on continue over here. Then I'm writing the source. What is machine learning? It is giving me the resources from where it is taking the answer. That is Perplexity AI. It also cites the sources. So as you can see, whether it is ChatGPT, Gemini, Claude, Perplexity AI, Grok, all these systems are powered by same core idea in maximum cases, the transformer architecture, the foundation of modern large language models. Let's get back to the slide. Now let's move to the next slide and understand how they actually work behind the scenes, starting with something called as neural networks. A neural network is a brain of any AI system. It is inspired by the human brain, made up of layers of neurons that recognize pattern inside data. Imagine showing a child hundreds of pictures of cats and dogs. After a while, the child learns to tell them apart, not memorizing but recognizing patterns like shapes, fur, and size. That's exactly what neural networks do with text. They learn which words appear together and what they mean in context. LLMs are simply very large neural networks trained on massive textual data containing billions of words from books, websites, articles, codes, Wikipedia, Google, and many more sources are there. Cool. All right. Let's move to the next slide and see the actual steps of how LLM processes the language. There are three major steps in how an LLM works. The first one is tokenization. The second one is embedding. The third one is transformers. The first step is tokenization, breaking text into small pieces called as tokens. For example, a large language models are amazing, might become large language model are amazing. Each model has its own tokenizer, like GPT uses byte pair encoding, BERT uses word piece. Let's actually see how tokenization happen in real life. We are moving towards the Google and we are typing platform.openai.com/tokenizer. We are here on the Google tab and we are just typing platform.openai.com/tokenizer. Then we are writing something called as large language models are amazing. You instantly see how it breaks into tokens like large language models are amazing. Similarly, on Hugging Face Tokenizer Playground, you can try the same text and even compare different models tokenizers like GPT-2 versus BERT. So tokenization is like teaching the computer to see words as building blocks. Let's get back to the slide. Let's move to the next slide, embeddings. Once we have tokens, the next step is embeddings, turning these tokens into numbers. Computers don't understand words, they only understand numbers. So each token is mapped to a vector, a list of numbers capturing its meaning. Words with similar meaning have vectors that are close together in the embedding space. You can think of it like a mapping of meaning where king and queen are nearby, car and bus are nearby, but king and car are far apart. To visualize this, go to the projector.tensorflow.org and search for the keywords. For that, let's move to the Google tab again. Let me open projector.tensorflow.org. As you can see, consider this as a 3D embedding space where all these circles are data points. I'm searching for the words, like I'm searching for Germany. You'll see them appear close together in the 3D embedding space. This shows how large language model understand the meaning through geometry. Let's get back to the slide. Let's move to the next slide, the heart of all the large language models, transformers. This is where the real magic happens, transformers. Introduced by the Google in 2017 in the paper Attention is All You Need. Transformer uses self-attention, allowing the model to understand how each word relates to every other word in a sentence. For example, the animal didn't cross the road because it was too tired. The word it refers to the animal. Transformer figure it out using attention scores. They generate a huge matrix of numbers that capture these relationships. During training, the model adjusts these weights so that it can predict the next word accurately. This is how it learns context and meaning at scale. And in the upcoming videos, I will break down entire transformer architecture, including mathematics, attention mechanism, and matrix operations step by step. So make sure you stay tuned for that. So let's move to the next slide and understand how this knowledge is stored. LLM stores two types of knowledge. The first one is parametric knowledge, the second one is source knowledge. Parametric knowledge is stored inside a model's parameter. They are fixed after model training. For example, ChatGPT already knows what Python is without connecting to the internet. Source knowledge is the knowledge which we will fetch dynamically from external tools, APIs, or databases. For example, ChatGPT with browsing or Perplexity AI with citing live sources. Together, they allow large language models to give relevant and factual responses. Let's move to the next slide and do some hands-on demo of actual models. Time for hands-on demo. Let's again go to the Google tab and just type huggingface.com/models. I'm just typing huggingface.com/models. This is the GitHub of all the AI models. You can search for any large language model over here. It can be GPT-2 by OpenAI, Bloom Chat, Llama 3, Falcon, Mistral, Neural Chat, Stable Diffusion, DeepSeek R1. Any model you can search it from here. For example, you are solving a use case with respect to object detection, then you should filter object detection from here, and you can select all these models. For example, you are performing video classification, select video classification from here, and you can use all these models. For example, you are performing, let's say, uh, text to video. You want to generate the video with the help of open source model, then you can click on this particular tag over here, and you can use all these models. So click on any model. For example, I'm writing something called as Mistral. So as you can see in the readme.md file, we have everything available, like what all commands are required to inference this particular model locally, as well as in the Google Colab. You can refer to this particular readme file and you can inference this particular model. If you want to see what are the limitations of using these particular models, you can read that particular readme. And if you want to see what is the size of this particular model, you just click on this files and versions tab, and you can see the size of this particular model. Click on any model, for example this one, and give your prompt, explain large language model in simple terms, and hit enter. The model will generate answer for you instantly. That's how simple it is to bring these models to life. Now let's get back to the slide. Now let's move to the next slide and see how they are actually used in the real world. LLMs have completely transformed industries. Let's see how. If I talk about chatbots and virtual assistants, we have ChatGPT, Gemini, GitHub Copilot, which help user interact with AI in natural language. If I talk about coding assistant, we have Amazon Code Whispers, GitHub Copilot, which uses large language model to write and debug code faster. If I talk about translation, we have Google Translator powered by the language models. If I talk about summarization and research, we have tools like Perplexity AI, deep thinking features by DeepSeek R1, O1, O3 models by OpenAI, Scholar AI, which are simplifying complex documents. If I talk about customer supports, automated ticket classification, personalized replies are there. If I talk about content creation, we have things like Jasper and Copy AI, which uses large language model to write ads, blogs, and captions. Basically, wherever there is text, there is an LLM behind it. So LLMs are rapidly evolving from text only to multimodal systems that can hear and speak. ChatGPT can now understand images, voices, and speech translation. And beyond that, we already have agentic models like DeepSeek R1 and OpenAI O1, O3 models, which can reason, plan, and act autonomously, connecting to APIs and performing real-world tasks. The line behind AI model and the AI agent is fading fast. Let's move to our final slide. The next step for you as a learner. Now that you know how LLM works, the next big thing is prompt engineering. Everyone has access to these models, but the person who can prompt them effectively becomes a real AI master. So in our next video, we'll learn the art and the science of prompt engineering with examples, templates, and live experiments. Don't forget to like, subscribe, and turn on notifications so you don't miss it. This is iNeuronics.ai. See you in the next video.